Yes, hello friends. Today we are going to learn a new algorithm technique called greedy method. Remember that earlier we have discussed brute force, divide and conquer, decrease and conquer algorithm technique. In similar way, now we are going to learn a new algorithm technique. Name itself is greedy method, right? So remember that if you have more than one possibilities, and this is our human tendency, is that always will select for the optimal solutions or best among available options, right? That is called greediness. So if you have a distance from A to B a 10 kilometer, right, then there is a distance from A to C is a 5, A to D is a 20, then definitely among these you are going to select the minimum distance. That is what called greediness. So based on this greedy method, you have a different algorithm to learn, right? Like we have a knapsack problems, job sequencing problems, Prim's algorithms, Kruskal algorithm, Dijkstra algorithms, right? So these all are based on the algorithm technique called greedy method. So let us see how and what are the concepts are there behind greedy method, right? What are the points to be concentrated in order to solve problems by using greedy method. So remember that greedy method, we are going to learn these all things. As I said that job sequencing problems with a deadline, minimal, cost spanning trees, we have Prim's algorithms, Kruskal algorithms, right? Then we have single source shortest path, Dijkstra algorithms, optimal trees, that is a very important problem called Huffman trees. And thereafter, this is the different algorithm technique called transfer and conquer approach. So these all things we are going to learn one by one under this module 3. So first of all, we are going to discuss what is general method for greedy method, right? So design technique applied to optimize problem, constructing a solutions through a sequence of steps. Each step expands a partially constructed solutions. Remember that we have mentioned that each step expands a partially constructed solutions. What it means? Remember that when we are talking about each steps, means we are looking for the feasible solutions, we are looking for the locally optimal solutions and irrevocable, right? So remember, when we are talking about feasible solutions, means based on the given constraints, based on the given conditions, we are going to find out which is what are the feasible solutions, right? Say feasible solutions, there is a difference between feasible solutions and optimal solutions. Friend, feasible solutions are solutions on all the solutions which satisfies the given constraints. It means we can have more than one solutions for the given problem scenarios, but among those feasible solutions, maybe one will be the optimal solutions. Now, what is the optimal solutions? If we are talking about the distance matrix or where you are calculating distance, right, then minimum distance is optimal solutions. Minimum time is optimal solutions, right? Time taken to perform the task should be minimum. Minimum distance to cover the distance is optimal solutions. But when we are looking for the profit, then each and every person will have tendency to make maximum profit. So in case of profit, right, we are looking for the maximum profit. Okay, so similarly salesperson will have tendency of maximize the profit, but postman who is covering all the distance for the dropping the letters home to home, their tendency will be to cover all the homes, right, in a lesser amount of time, lesser covering lesser distance. So optimal solutions change, sometimes for the minimum, sometimes for the maximum. So depends on the problem scenarios. So remember that feasible will be having more than one solutions for the given constraints. But in each and every point, for each and every given problem scenarios, will be having multiple ways. Among that, which is optimal. Okay, so we are looking for the local optimal in each and every step. So see, best local choice among all the feasible choices. Then irrevocable, it means what? Once you made, it cannot be changed on subsequent steps. Means we have to go in the same direction by considering that whatever the selections you made it, we are not going to walk back and we are going to perform the task one after other. Let us see what are the points to be considered in your mind. Remember, when you are talking about the greedy method, say we have an, where A is the arrays of n elements, right? And you know that how many input is considered is n input. Initially we don't have any solutions, right? So solutions is equal to 5. Now we are going to check for that. I is equal to 1 to n possibilities. X is equal to select A. If I have selected A, but this is the feasible solutions, right? If feasible solutions comma x, then we are looking for that particular feasible solutions is really giving you the optimal solutions or not. If it is yes, we are going to include that. See, remember, in a solutions we don't have any element. Now we have added x as a x you made as a one of the local solutions, right? So that will get union with solutions. So we have x. So likewise, we are going to perform the task again and again, and finally, whatever the values are getting at end, that is called final solutions based on the given problem scenarios. Look, what are the points to be considered? Okay, first, candidate set. The set the solution is made from, right? So say if you have a 5 vertex, so out of that 5 vertex, right, we are going to select one by one. So that particular set of 5 vertex is called candidate set here. Selections functions determine next candidate set member to be selected. So among that, maybe this is our independency based on the given problem scenarios. We are going to make our own, based on our own understanding, we are going to select one of the choices out of it. So that feasible functions can the current candidate set be used to help construct the solutions. Remember that based on the given constraints, we are looking for that particular selection is really feasible or not. Alright. Thereafter we have objective functions. What objective function says that looking for the optimality. Optimality means optimal solutions. How good is the current solution is. Remember that if current solution is not good enough, then in the next iterations maybe we'll be getting different choice, different selections you are going to make it. If first one is, say as for example, if our direct distance from A to B, say it is 20 km direct distance, but we found that there is indirect distance A to C and C to B. So A to B is 20 km, but here A to C is 10 km and C to B is 5 km. So if you are going indirect way, A to C and C to B is still 15 km, that is lesser than the direct distance from A to B. So we are going with A to C and C to B, right? Solution function is the current solutions or complete solutions. Okay, is the current solutions or complete solutions. That is a solution function that will get it as an end. That is called based on the given problem scenarios, will be getting different optimal values. So this is all about your general method of greedy technique. Right, now let us go a little bit in details by considering some example. So this is one of the important problems called knapsack problem. Now you try to remember that knapsack is a name. What is knapsack? Knapsack is just a bag, okay, or container where we can put some element, right, or you can put some selected element. So what is this basically? Knapsack is, we'll be having different say items 1, 2, 3, 4. So these all are the items. Remember that all items will have their own weight. So all the items are associated with the weight. So weight is 10 kg, 5 kg, 20 kg, and 15 kg. So these all are the first element weight is 10 kg, second element weight is 5 kg, third element is 20 kg, 4 element is 15 kg. Now we have a profit. We have a profit of all the elements. Profit means what? Say this is the profit is 40, here we have a 50, here we have a profit is say it is 20, and here we have profit say it is 45. It means all items is having their own profit and we are having their own weight. Alright. So this is exactly what problem is given. Now you are going to apply greedy knapsack to solve the problem. What is greedy knapsack is? Now that knapsack, what I said you, it is a container or a bag. So each and every bag will have the capacity. So this bag is having capacity of, say as for example 30 kg. Okay, so M is what? We are talking about capacity of bag. Capacity of bags. So M is equal to 30. So this 30 kg, we have to select an item such a way that maximum profit we are going to generate out of this 30 kg. We cannot keep more than 30 kg weight in knapsack. So let us see that what are the problem scenarios you have. Given a series of items with the profit and weight, and knapsack with the maximum weight it can hold. That is, I am talking about the capacity of the knapsack. What is the maximum profit of item you can carry? Assume an item can only be added once. So look, here we have different possibilities. Some person will go say that okay, 30 kg, I will select this and 10 and 20 kg. It has become 30 kg. So profit is 40 plus 10. 40 plus 10 is 50. Profit is 50. But someone will say no, I will not make this choice. I will go with choice like 10 kg will be having this 5 kg and will be having this 15 kg. So now if you see that profit, it is what? 40 plus 50, 90 plus 40, 135. So first case we got profit 50. Second choice we are getting profit of 135. Right? Now anybody can tell that 135 is maximum values. So we'll go with selection with first element, second element and fourth element. That will give you the maximum profit. Candidate set is what? Item available to add. So we have 4 items to add. Selection functions, item must be selected based on the largest profit divided by weight. I will discuss and solve it why this profit divided by weight is. Right? Feasible functions, does this item make the solutions weight greater than the maximum capacity of the basket? If not, then add this item to the solutions. Objective functions, find how much weight is left in the basket. Right? Remember that when you are adding this 10 kg and 5 kg, it is 15 kg. Is it less than 30 kg? Yes. How much? 15 kg. So we are going and selecting with the more profitable elements. How are you going to select more profitable elements? Not this 20 kg, why you will go for 15 kg? That I will discuss with an example. Right? But we are going to select the item such a way that we can have maximum elements in the given knapsack or bag such a way that it is going to maximize our profit. Solution functions, if there are items left in the candidate set and the basket can hold more weight, then repeat it, otherwise solutions has been found. So this is basically, we have correlated knapsack problem with these all 5 points, which is remembered to be implement greedy method. Okay, basically it's not like that we are going to implement all 5 points, but yes, most of the greedy method when you are applying it, these all are the 5 points will be coming in one in after other way. Let us see that in example. This is find the optimal solutions to the knapsack instances. Number of element is 5 and weight total capacity. This is basically friend capacity. Capacity of knapsack. Capacity of knapsack. Oh, okay, 10 kg. Now here we have 5 elements. Say it is 2 kg, 3 kg, 5 kg, 4 kg and 1 kg. And their profit is given P1, P2, P3, P4, P5 is 6, 3, 10, 16, 3. Right? Now, I am just going to ask you, or you can understand. Say, a thief is entered in any house, right? And he is having options. He is having bag. He is having options, or for gold as well as silver, right? Then definitely, based on your understanding, right, person will select gold first. Why? Because gold is more profitable. Right? Gold is more profitable. Similarly, based on the given, how you have decided it is more profitable? Because we are going to check what is the profit of that gold divided by their weight. Right? Remember that 10 grams of gold, say it is 50,000, where 10 grams of silver cost is, say it is 2,000, right? Then definitely we are going, which will give you the maximum profit is gold. And how you have decided? Total profit divided by weight, right? Like this. But remember, if thief entered in the home to select some items, but there is no items in house, then what is the overall profit? It is 0, right? But one more scenarios. Say thief entered in the home with empty bag. A bag is not going to hold any items. It is just a paper bag, right? But there is lot of item in the home, right? In that case, what will be the maximum profit? It will remain 0, because that bag is not going to hold any items. We are not going to select any item. But first case, there was big bags, but we don't have any item to keep it. So profit is 0. Otherwise, we are going to select the items based on the profit divided by weight. Then only we decide which element is having highest profit. Okay, so let us see that based on these algorithms, what you are going to do it? We are going to first make profit divided by weight, and we are going to write it in non-decreasing order. Okay, so let us see that. Here we have 5 items. Say it is 1, 2, 3, 4, 5. Okay, these all are the item. Now here we have weight. Weight is first element, weight is 2, second element is 3, then we have a 5, then we have a 4, and we have a 1. Thereafter we have profit. We are going to write 6, 3, 10, 16, 3. Look, we have a 2 kg, 3 kg, 5 kg, 4 kg and 1 kg. Corresponding profit we have. But first of all, we have to make computer to understand which element is having highest profit, right? So we are going to find profit divided by weight ratio. Profit divided by weight ratio. So 6 divided by 2 is 3. 3 divided by 3 is 1. 10 divided by 5 is 2. 16 divided by 4 is 4, and 3 divided by 1 is 3. Right? Now, if I'll ask you which is the most profitable elements out of it, which item is most profitable items among these? Everyone will say that, okay, this is the 4th item is having most profitable item, because per unit or per kg, right, we are getting 4 profit, right? So we are going to arrange this decreasing order, right, of their profit divided by weight ratio. Look, we are going to sort all the items in decreasing order of their profit divided by weight ratio. In that case, which one will come first, friend? 4th. So in that case, there is the 4th item. Item is 4. What is their weight? Their weight is 4. Their profit is 16, right? Similarly, and profit divided by weight, we are getting 4. Thereafter you can see that this is a 3, this is 3, so anyone can come first. So let us see that first element, weight is 2 and profit is 6, hence 3. Similarly, fifth element, we have weight is 1, profit is 3, hence it is 3. Then we have among this 4, 3, 3 is done. Now 2, that is third element. What is that? Weight is 5, profit is 10, and profit divided by 10. 10 divided by 5 is 2. And last is second element is 3, weight is 3, profit is 3, hence profit divided by weight is 1. What happened, friend? We have written these items based on profit divided by weight in decreasing order, and we got this order now. Based on the given problems, what is the W? Capital W is given 10. It means we are going to select the items such a way that maximum weight will be 10. So look, how are you going to select? Anybody will say that, okay, let us see that first element, what is the weight? 4 kg. Total capacity is 10 kg, hence first element is selected. Okay. So see that total weight is 10 and fourth item weight is 4. Hence, is this 4 is lesser than 10? Yes. Then item 4 is selected. Item 4 is selected. If item 4 is selected, then what will be the solution as of now? Just I am writing total profit is equal to what? Profit of fourth element. Profit of fourth item, that is 16. Let us see that again. Since 10 is lesser than, 4 is lesser than 10, it means complete 4 kg of items you can select. And if you are selecting 4 kg of item, what is total profit as of now? By selecting one element is 16. So that is we have done it. Now, in a knapsack, this is the total capacity. In knapsack, how many kg is left now? 4 kg is done out of 10 kg. So we are going to select, okay, remaining weight. Okay, for the knapsack is 10 minus 4 is 6. Still 6 kg we can add. Still 6 kg we can add. Okay. Now, since it is non-decreasing order, it means we are going to see that what is the next profitable element. Next profitable element is first one. And what is the weight? 2. Profit is 6. So we are going to check that whether we are able to add complete 2 kg or not. Yes. So we have a 6. Is this 2 is less than 6? Yes. Then what happened? If it is yes, then select first item. Okay, select first item. If you are selecting first item, then what will be the total profit? Total profit as of now is 16 plus profit of first item. Right? So basically 16 plus 6 is 22. Now remaining weight you are going to calculate again. Remaining weight in the knapsack. In the knapsack. What is remaining weight? We have a 6 kg. 6 minus 2. Now we have only 4 kg. We can add again. So again you are going and checking back. What is next profitable element? Is 5th item. And what is the weight? 1 kg. What is profit? 3. So let us see that. Is 1 is less than what is remaining weight? 4. 1 is less than 4. Yes. Select which element? Select 5th element as well. Select 5th item. In that case, what will be the total profit, friend? Total profit is equal to 22 plus, and what is the profit of 5th item? Is 3. So it is 25. What is third? 3 here. 3 is profit of 5th element. Profit of 5th item. Now we are going to find again total profit. Total profit is done, and what is the remaining weight as of now? Remaining weight, okay, in the knapsack is 4 minus this 5th element item weight was 1 kg, so now it is 3. So now we have a 3 kg, we can add it. Now let us see that. What is next item? Profitable item is 5, profit is 10. All of you please concentrate here. Please concentrate here, because greedy knapsack says that we can select the fractional weight. If you are not able to select 5 kg to the bag, since we can select maximum of 2 kg out of 5 kg, then we can select the 2 kg only, right? No need of keeping that bag empty. So out of 5 we can select 2 kg. Hence, if 5 kg is a profit is 10, then what will be the 2 kg profit? We are going to compute it, right? So let us see that how we are going to address these issues. So next item is 5, weight is 5, profit is 10. All of you try to understand it. In that case, we can have maximum of 3 kg. So let us see that. Remaining weight, we have 3 kg, 3, and as of now total profit we have 25, as you have discussed, right? Now next is what? We have a third item. Weight of item is 5 and profit is 10. All of you please concentrate. We have only 3 kg weight is left. So this 3 kg you are going to find the fractional weight, how much weight you can select. So out of 5 you can select 3. So fractional weight we are going to compute. So out of 5, 3 kg means, can we write 3 divided by 5? Yes. In that case, what will be the fractional profit? Profit of fractional item. Okay. In that case, what will happen, friend? 3 divided by 5 into profit. What is the profit? Total profit was 10. So 5 to the, so it is 6. Profit should be 6. So remember that 5 kg profit was 10, hence 3 kg profit will be 6. So that is going to compute in total profit. So total profit is equal to 25 plus 6 is 31. Is our optimal solutions. Is it our optimal solutions? Right? Here you get 31. And remaining weight. What is remaining weight? We have to stop this. Once we are getting remaining weight is 0. So look, remaining weight was 3. 3 minus, right? How much weight we have selected? We have selected 3. Hence it is 0. Hence it is 0. So we'll stop here and we'll call it as this is our maximum profit. And maximum profit is 31 for this knapsack problem. 31. Okay. Maximum profit we got 31. Now let us see and compare with our algorithms. Right? Look, what happened, friend? We are in greedy knapsack. We have weight of n items, profit of n items, and this is total capacity of the bag. This is already given in the problem. Now I is equal to 1 to n. We are just writing x is equal to 0. X is equal to 0 means we are just keep tracking of what element we have selected for the knapsack or not selected for the knapsack. Weight, initial total weight of the element selected for the knapsack is 0. Right? I is equal to 1 to n. Do weight plus W of I. Weight, total weight plus W of I is individual weight of ith item is less than the capacity. That is what we did it in each and every iterations. If sum of the weight selected for the knapsack is remain lesser than capacity of the knapsack, then you are going to select. So this W of I, if lesser than the capacity, we are going to make x of I is equal to 1. So this is individual item you are going to select. Okay. Individual item we are going to select. If x of I is equal to 1, that item is selected. If that item is selected, then weight will be weight plus W of I. If it is selected, weight will increase for the knapsack. Else, say we are not able to select because this is above capacity. What happened in the last iteration, friend? In examples, we have 5 kg items. If you are going to add it in the total capacity that required is 3 kg only, then it would have gone more than 10. Means we are getting 13. Right? So we have required say 7 plus 5 is 12 and maximum capacity of the knapsack was 10. Hence, we are not going to select. If you are not going to select this x of I is equal to 1 or that individual item, complete item you are not going to select. What we did it in example? We have taken that required weight divided by total weight of that items as a fractional weight. So let us see that x of I is equal to weight minus weight, right? Means total capacity of the bag was 10 and we have in knapsack 7. So 10 minus 7 was 3 divided by weight of items. Weight of item, last item, third item, what it was? 5. So 3 divided by 5. So we have computed this in our examples in last iterations. 3 divided by 5. Now, look, if that is case, weight is equal to weight means if in a knapsack capacity we have a 10 kg and all 10 kg we have selected, we are going to break it, right? So this is basically how you are going to select the weight and accordingly you are going to compute the profit as well, right? And we have shown in the example. So say second example, say here we have item, weight and profit. Say we have first item, second item, third item, it is 25, 24, 15, right? Okay, so take it this as a profit, friend. This is as a weight because just I am discussing as per your textbook. Weight, say it is 18, 15, 10. So if you are going to do the profit divided by weight, this is the profit. Profit divided by weight. What will happen here? it will give you 1.3 values. Here is 1.6, here 1.5. Right? It will give you 1.3 something. So among this, if you see that which is most profitable element is second item. And capacity of this example is given, say as for example, capital M is 20. So maximum you can select 20 kg of items. So look, if second is more profitable elements, because what we did in first row, write it again in decreasing order of their profit and weight. So which element will come first? Second element, because most profitable elements. Then last is most profitable element. Then last place will be there. Element is having 18 kg weight and profit is 25. So this you are going to select completely. If this you are going to select completely, what is the knapsack weight? 15, 20 minus 15. 20 minus 15. Still 5 kg we can select for the knapsack. And what is the profit as of now? Total profit is 24. But 5 kg we can select. 5 kg will select from where? Third element and first element. Based on our concept, you are going to select from the third element because third element is most profitable element. But how many kg we can select from the third element? Weight is 10 kg. We can select maximum 5 kg. So what is the fractional weight? We are going to calculate fractional weight based on this concept. W minus weight, 20 minus 15. 20 minus 15 is 5. Divided by weight of I, weight of this element. What is that? 10. So it is 1 by 2. Now if you are going to compute total profit is equal to 24 in the previous iterations plus 1 by 2 into what is the profit of this third element? We have selected 10 kg profit is 15, then half. 5 kg profit will be 7.5. So we are going to write 24 plus 7.5, hence it is 31.5. Right? So this is another examples. We can solve it, right? And we can see that we are getting 31.5. But look, if you not having idea of knapsack, if you are not having idea of greedy technique, then we would have selected this element first. You have selected this element first. If you are selecting this element first means what? 18 kg gone. If 18 kg gone means what? Only 2 kg is left. And if you are selecting 2 kg from here, right, then your profit is not going to be 31.5. It is going to be lesser compared to 31.5. So maximum profit we are getting based on this greedy knapsack. I hope you would have understand this and make knapsack. So today we learned about greedy knapsack and greedy method concepts. Thank you very much.